Here, Guy, I promised you to invite to our after party. Hi there, I'm Ksenia, and I'm helping Apache Ignite community with project awareness. And let's, while we are all gathering here, let's start with a quick poll about clouds. If you have here speakers, guys, please push the button, share audio and video. Because I want to start from several questions. Hi, Denis. Several questions about clouds. And some of these questions were after the polls we had during the event on the stage. And one of them was about where do you plan or where do you run Ignite? And one of the most popular answers that were was on-premise. Next followed private cloud and some public clouds, and very few people choose the hybrid infrastructure. So my first question probably will be, so what do you think about hybrid infrastructure using clouds and on-premise in one architecture? Maybe it's too complicated, or that's just too modern, or what's your choice here? What you would tell about hybrid architecture? Hi, wow, nice to see you here.
Yeah, if you want, I can start.
Yeah, please start
here. And then just in case, I see that there are 9 guys who are watching this. Guys, yeah, just don't be. Just share your camera, join us, because many of you, I guess, deploying and running Apache Ignite in the cloud. I mean, from the hybrid cloud perspectives, I truly liked the talk by Stan Lukyanov earlier today. He basically laid out a lot of different reasons why this happens. That certainly happens because even if you take a big company, there are a lot of data silos. For instance, one department might be running one database. The other team in that company can be running another set of databases. And the same company has to develop, has to innovate. What Shahir Dyer from IBM was talking today, right? Like you have to create new types of services, and those new types of services require you to provide like access to all the existing core systems and other types of data stores. And what's interesting is that all those like core systems and other types of databases can reside in different cloud environments, in different regions. And that's why it happens when you can deploy hybrid architecture because of, let's say, because of their high availability patterns, or because of the access patterns, because some of the applications are deployed in one cloud environment, the others are deployed in a different environment. And also what we hear by talking to some of our enterprise-grade customers, they deploy hybrid architectures because they don't want to get that vendor lock-in. For instance, big corporations, they might select AWS as a primary cloud provider, but at the same time, they're not investing all the resources, everything in AWS, and they will be using, for instance, Google Compute Engine or Azure as a secondary cloud provider. And the different instances and different types of applications and services might be running here and there, and sometimes you need to synchronize data sitting in AWS or Azure or Google Computing Engine. That's my take on this question.
Good, guys. Any other opinions, maybe, or any additions to this? Okay, in that case, our next poll that was about clouds. And speaking about clouds, of course, most popular AWS and Azure, but also private clouds. And my question is, what do you think? Is it possible for a company to use private cloud only and not to use any external cloud providers? Or that's too outdated? your opinion?
Maxim, actually, Maxim, it's interesting to hear your thoughts here because, like, you work for Sberbank, and Sberbank certainly has a lot of, like, huge private data centers. Like, what guys are you doing? Like, are you moving to any public environments, or like, are you using only
Yes,
private infrastructure?
actually, I work in 2 companies that has private clouds. The first one is the Mail.ru group, and I was a member of a team that built a private cloud inside the Mail.ru, and this was our solution for our developers that need to test something and they need to run some applications for testing our services inside our company, because we have a lot of machines and we have only 3 DevOps, and we build the private cloud to make their work a little bit less stressful. And for Sberbank, it's we also has our private cloud because we have very strong men in our security department, and they forbid everything. And the only thing we can do is use a private cloud. So it's not very old. I think it's great when some companies can build a private cloud on their hosts. I think it's okay. Why not?
Good.
Yeah, I mean, it's and you remember like what happened with Amazon. Amazon was like among the first cloud providers who kind of started this whole transformation. But Amazon was using once, like, they created AWS for their internal needs for the Amazon marketplace first, and only after they kind of were able to scale and develop all the tools, all the infrastructure, they started selling Amazon cloud like to everyone else. And what I hear, like for instance, Sberbank certainly has a lot of private resources, right, data centers, and what we see right now, at least in Russia, you can use Sber Cloud, right, as a public offering. Same story that happened with AWS, same happens with big players. But when it comes to what also I hear, what I see, let's say companies who deal with sensitive data, like Sunil was talking about healthcare, and probably it's interesting to hear his opinion. Sunil, if you're still here, please join our conversation. My sense that like many healthcare companies, like healthcare providers, might be preferring, if it's possible, just to keep data in private data centers if they can afford it. Otherwise, you go to the cloud. Fintech, like many banks, they still use hybrid infrastructure when there are private data centers where they keep, let's say, some sensitive data like accounts, transactions, etc. And also they use public clouds for different reasons. Even like you might have heard about products such as AWS Outpost. It basically when you can use the same services by AWS, but AWS will ship you appliances that you can deploy in your kind of buildings, and then AWS team will be managing services for you. But those appliances will be deployed on your perimeter in your data center, but you are going to get the same level of service. It's all, I think, driven by type of data, but both private and public makes sense.
Speaking about GDPR, Courtney, maybe you have here an opinion because your company is operating in the UK. Do you feel like all these restrictions about the data, GDPR and stuff, somehow maybe stopping the cloud growth, or no?
I don't know about stopping cloud growth per se, but it does make things challenging. Because right now, for example, we're in the middle of actually our new experimental setup. So up until summer this year, we were only deployed in the EU. So we only had a single Kubernetes cluster running in the EU. But as we're expanding now, we're looking at 2 other data centers, one in Asia and one in the US. And we've basically been having to build out additional infrastructure to be able to make sure that EU data stays in the EU. because some of our customers, their data just can't leave the EU. So I don't think it really constrains the growth of cloud as such, but it does increase I think the amount of work that service providers have to do in order to be able to provide the same level of service to different parts of the world. It does make it more difficult, but I don't think it's a limiting factor per se.
I've heard the thing about Russian, but I think that while I was reading about cloud trends for this Q&A, I met a strange thing like shadow cloud usage, which means that people who are restricted to use any public clouds but need to develop something fast and need to make some fast POCs. They just use clouds without permission. Does anyone else except Russia has it?
I think it's a global thing. I don't think it's specifically Russian related. I've known one customer in particular who they had some of their staff that, for exactly what you just said, for POCs, they would AWS clusters to do like small demos for different teams, that kind of stuff. And I never got into the detail of how they ensured like certain data didn't get to the cloud, but they were doing that even though technically the organization doesn't support public clouds and they're not supposed to. So I don't think it's a Russian specific thing. That customer was in the US.
Oh, interesting, because I didn't find that thing in a trend. People were talking about next level of integrations, something like, public, but a little bit more private story. Well, interesting. So talking about clouds, and that looks like everything would be at least hybrid in next some years. So do you think that we need some new special skills for engineering teams who are building such solutions which need to be cloud native or hybrid?
So we've found it challenging to find engineers who have the skills to be able to work with certain technologies that we're using, Ignite being one of them. But we have a pretty diverse stack, so we use things like Pulsar, etc., as well. And finding one engineer that is familiar with all of them has been an impossible task. We've yet to find one. So it means that there are a lot more people who are kind of specialized on a single set of technologies. So you might find people who are specialized in like streaming tech or something else, but it's really hard to find people that can work across the entire stack. We've certainly struggled finding people able to do that.
And what do you mean by full stack? Do you have some set of skills that you need? It's like 1, 2, 3, 5, or what do you mean by full stack in the cloud sense?
Right. So I mean mainly across the different cloud providers. So we deploy for our own redundancy. We deploy across OVH Cloud and across AWS, and within each of those, our platform uses Ignite, that uses Pulsar, Cassandra, and a number of other services. And finding someone who knows both AWS and OVH, plus all the other tech that we're using inside that, has been a challenge. So that's what I mean.
Inside, I think there is no some specific skills that are required. In case you're finding a person who wants to develop a cloud, it is one task to find such person, and it definitely should have some skills. And from the other side, there are people who just uses clouds, and it means that they iterate over API and they use very known patterns. And every good engineer will can teach these things and will not any problems to be on the line in the project for 2 or 3 weeks.
Well, so it's not like a skill set, that's like a mindset. Val, in that case, I have a question for you. As far as I understand, Ignite, when it was just at its start, that was on-premise solution. And speaking about our next major version, Ignite 3.0, would it be cloud native? And do you feel that some approaches were different? Speaking about how it will work in the clouds.
I mean, yeah, historically, of course, Ignite was initially designed more as an on-premise solution, obviously, just for simple reason clouds were not as popular back then. I wouldn't say that Ignite is not just a purely on-premise solution even now. You obviously can run it on cloud, you can deploy it on clouds, you can use it on clouds. With certain challenges, sometimes with certain limitations, but you can certainly do that, and users and
we have Greg here who's running it in Nebula.
Yeah, so we definitely do that on cloud a lot nowadays. Ignite 3 just makes a step forward towards this kind of cloud enablement direction. We obviously understand that there are more and more companies transitioning to clouds, and we want our platform to be much easier to use in the cloud environments. And basically, all the development that we're doing right now is kind of oriented towards that. So we're essentially going cloud first in terms of all the changes that we're doing. On the platform side, we're doing several changes that we believe will make it, more suitable for cloud deployments. There are a lot of usability improvements, first of all, because in clouds we just when you run something in a cloud, you want it to be essentially a click away from having a cluster and being able to deploy it there. There are improvements in code deployment, for example. We obviously want to make sure that it's easy to deploy your code in the cluster that is running somewhere remotely, because on premise you can just physically copy jar files, and it's relatively easy. In the clouds there are certain limitations in terms of that, and we want to provide those mechanisms. On the internal architecture level, there are also changes that we're making specifically around replication protocols, and we are switching to Raft, which is kind of I would say an industry standard at this point, and it allows you eventually will allow us to achieve multi-cloud deployments and better segmentation protection and all those things that becomes more important when you run your platform not on your own hardware, I would say, right? Because when you're isolated in your data center, it's much less challenging in that regard. So we're doing that as well. And also, maybe Greg can talk about this a little bit more, but at GridGain, we're also working on Nebula, which is the managed service for both GridGain products, but also for Ignite platform. And of course, this will be natively integrated with Ignite 3 when Ignite 3 comes out, and you will be able to use Nebula to run your Ignite 3 cluster, to provision your Ignite 3 cluster and manage your Ignite 3 clusters in the cloud environments.
Okay, and my question about with our bright future in the clouds, I think to all of us, if we are going to a cloud with most of our applications, does it mean that microservices architecture will be the winner in that evolution?
Let me start here, and if just to step back a little bit and briefly share some thoughts on the previous question, like whether Ignite is like cloud native, etc. Ignite is Postgres and MySQL. It will remain as a software, right? What we do at the community, we develop software. It's always will be possible to download it, which means that you have a freedom of choice. And but when it comes, and what Val says, but from the API standpoint, from the architecture standpoint, certainly the community takes into account that a lot of deployments are going to the cloud. That's why we are planning to optimize the core engine. But Ignite 3, like 4, whatever, 5, it will remain as a free software that you can download, install on premises, etc. And certainly we will see that more and more types of cloud native services will emerge. So right now, for instance, we know that GridGain offers Ignite as a service, but who knows, like in some time, like many other cloud providers can start offering Ignite as a service, because they will have that opportunity. They can download Ignite and they can sell Apache Ignite, offer Ignite for the cloud. As for the microservices, I truly liked, the point of view of Shahir from IBM, who was talking several hours ago today. He basically laid out a wonderful use case when he was dealing with a lot of upgrades with some bank, and the bank was trying, to do the big bang upgrade, when you just take the whole monolithic application and try to upgrade it like in one cycle. And usually, if someone disliked a color of your button because you did not respect, the branding of your company, then your whole upgrade would be reverted of the whole application. That's a good story of why would you switch to the microservices. But also you have to balance, right? What level you want to, how many microservices you want to have, because it doesn't matter, to introduce 10 microservices, when most likely you just need to have 2 microservices running, right? That's my opinion. Microservices architecture sounds great, but also try to find the balance. Don't overcomplicate, because all those microservices have to interact together. They have to exchange data. They have to send notifications to each other. And the more microservices you have, the bigger the complexity. So that's why pick the right number. But overall, microservices sound great, especially if you refer to the Shahir story I remembered.
Is that Ignite is a very big system, and it's not split on some microservices, and it still works and works very fine, fast. So
yeah, it can even be used to deploy microservices to a certain extent,
yes.
Right? I mean, I would say that it's, I don't think that running in the cloud kind of inherently means that you are switching to microservices anywhere where you can. We're essentially moving everything to clouds nowadays, right? And including even monolithic applications as well. And as Denis said, I think the truth is somewhere in between. And we will essentially end up with a certain mix of monolithic databases and certain applications that run on their own, and microservice applications that are basically kind of there. And the cloud will help us to integrate all this into kind of a single ecosystem. I think that's the role of the cloud here.
So I think for us, and I can only speak from a personal perspective, well, from the company's perspective, it's more about tooling and integration with the various cloud services, right? Because obviously each of the cloud providers, yes, you can potentially do something that's generic and works across different clouds, but if you're in AWS, they have a certain way of doing their networks. If you're in Google, they do another thing, right? So I think from our perspective, and where the Ignite community fits in, or the Ignite and GridGain as a product fits in, is what kind of integration is there with the major cloud providers. So, for example, the IP Finder stuff that was discussed earlier, those things were added in to do discovery of IPs in an AWS environment, right? So it's about how easy it is to take advantage of the various utilities that these cloud providers are having available. So that's where I think cloud native really comes in. That's the kind of thing that comes to mind when we talk about cloud native. It's how closely does this tool, in this case Ignite, work with a particular cloud provider or various cloud providers.
Greg, and your opinion?
Yeah, I would say, at least in our experience, I mean, just to build on what Courtney said, it's always a balance that you have to find between when you're building like a cloud native service, how much do you commit to the platform specific APIs and platform specific utilities versus, are you able to, use more generic technologies? Because if you're, something like our service where we want to deploy or support deployment across multiple cloud providers, it's more work if you're going to, go very deep into like the AWS APIs, and then you want to go take the service into, say, Azure, and then you have to kind of relearn all of the kind of Azure way of doing, networking security and provisioning and everything? Or are there, ways that you can get around that by finding like more generic solutions through, other means?
I just want to thank all of you guys who organized this event, who presented and shared the knowledge, and who supported. Because I unfortunately have to run. I have to pick up my child from school. But I truly enjoyed. Like I contributed a little during this event, but at least I enjoyed, listening to the talks, participating in discussions. So look forward to attending the next summit. So thanks a lot to all of you guys.
Thank you, Denis.
Thanks,
Denis. By the way, guys, if you want to ask some other questions, because my questions were mostly about trends and details. If you have some questions about details or about talks, you can also join us and ask them or put that into the chat. My next question is also about nice new word like distributed clouds. I mean that actually all the clouds were somehow probably distributed, so nobody cared where exactly these servers were. But now it sounds like it's an advantage to know that your cloud covers several regions, and you can save here some seconds maybe, or parts of a seconds. What do you think about that? Is it a real thing or just another trendy word?
I don't know about distributed cloud as a term itself, but so one of the things that's important for us is, being online. I think because of the quality of service that people have come to expect from major applications that you might know, if your application or your service goes down, the blowback from that can be immense, both from a trust perspective for your customers and a financial perspective. And so when distributed cloud for us isn't necessarily with a single cloud provider, but with multiple cloud providers. So we'll do multiple regions with the same cloud provider, and then do multiple regions with another one. Because if, like, for example, a single cloud provider could have some global outage, which has happened, right? It's not unheard of. It's not very often, but it does happen. And in those cases, having your service being able to stay online while the cloud service provider, one cloud service provider is offline, is super important. And so, because I guess the advent of cloud has made a lot of things more accessible and more affordable in some cases, you are able to basically say, okay, deploy your platform on this cloud provider in 2 availability zones, and then replicate everything over to this other cloud provider just in case. Obviously, the cost of that, can sometimes be immense depending on your requirements. But if being online 100% of the time is kind of a thing you have to do, then you don't really have much of a choice.
That sounds like a real challenge for the monitoring of such systems. So, Greg, my question is to you now. If you have such a zoo of the clouds on many projects, how will monitoring change in that case?
Yeah, I mean, if you can put together like a centralized monitoring system that can span across multiple clouds, then that would give you like a single pane of glass for how to basically check up on the systems that are running in different data centers and across different clouds. That was kind of the goal when we launched our initial SaaS offering for our control center. So that's just a centralized monitoring tool, and you basically just provide the connection information credentials to the cluster that you're managing. And then we can give you all of the monitoring tools for it. And those clusters could be on-prem, they could be in AWS, Azure, Google Cloud, whatever.
Sounds good. Sounds good. And while constructing such a complicated system, I guess that it should be a challenge. So what can be the tips for the people who are in the process of creating their architecture? Maybe what to pay attention to, because that looks like best practices from 5 years ago, not best. for the next 2 years, for example?
I mean, I think the general answer here is it depends on what you're doing. Obviously, there's this whole story about edge computing, for example, right? I don't know if that's part of this distributed clouds story, because to be honest, I'm not familiar with that particular term as well. But
Gartner says it's a different one.
Okay, but yeah, like the edge computing is also interested, and I think I think it's related anyway, right? Because it's also about having like the whole, not just multiple clouds, but having a hierarchy of clouds. And you have like bigger clouds. You have a central cloud which has all the data and maybe a couple of them for for redundancy, for replication. Then you have smaller clouds, and then you have edge clouds, which are kind of closer to the devices and to the consumers of the data that you have. And the consumers also might be moving, like if there are like the cars that we have right now that also access internet every second or whatnot. So they also need to have access to the data and to be able to update the data very quickly with a very low latency. And obviously, in order to achieve that, you need to have your deployments very close to those devices. So it's a huge story, and I guess we can talk a lot about this. And there are a lot of challenges as well. And I think it's kind of trending right now, to be honest. I've seen multiple like conversations and different articles about this lately, so I think it's becoming a trend nowadays. So we'll see where it goes, and honestly it's hard to predict. Again, I think the truth will be somewhere in between. Of course, it's not going to be a solution for everything. We'll still for the majority of the use cases for the next several years, we'll stick with the deployments that we have right now and kind of with the approaches that we have right now. But there are definitely use cases that require those more complicated architectures.
So you say it depends on what are you building, right? And what do you think in that case about industry clouds, like healthcare cloud computing market, or finances cloud computing market? That looks like there are some numbers which are really great. People are evaluating these markets in a few next years. Does it make sense to you dividing clouds by industry, or that's just marketing?
I'll take a stab at this one. So I'll just build on Val's comments earlier. I agree to the previous question that it depends on use case, but one thing I will say is that regardless of what you're doing at the architecture level, you need to plan for failure, because it's inevitable that it will happen. And there was a time where people would literally stay up all night making sure that something doesn't go down, and that if it does, you try and get it back online as quickly as possible. But in these cloud environments where you don't have as much control as you used to, your cloud provider could disappear, right? You could end up with network situations where you can't even connect to your cluster. Some customers are able to access, but you're not able to access. What do you do then? So you've got failure scenarios. And from the architecture, the question you asked earlier about the architecture and what you should plan for, I think failure is number one. And then to the subsequent question, I think it makes sense for some industries. I don't know how widely it will apply, but like, for example, one of the talks that we had earlier about 5G and the networks that are basically up and coming now, right? So imagine the surgery use case that was given in that talk, right? In those cases, it makes sense to have the kind of infrastructure in place that pretty much guarantees that you're not going to get disconnected halfway through surgery, right? If that happens, people die. And there are other cases even today where, the things that you build, the services you provide, people's lives actually depend on it. And so you can't afford to go offline. So I think it does make sense to have specialized, maybe not even specialized clouds, but services that are basically trying to guarantee that you're always online and you don't get the failures that I keep mentioning. But again, how widely available or applicable that becomes is a question, I think, for anyone.
Here are some that, for example, if you have some manufacturer and you have some complex devices that works on some protocol that is not very represented in other industries, it will be very useful to have some cloud that's specific for this situation, because from other side you should to make some additional layer between the devices and your cloud, and there are possible issues for losing data, for losing information about devices or something, etc. So I think it is possible, but it really depends on devices you use.
Yeah, and I think generally speaking, every industry is unique, and for every industry, you can probably think of certain set of kind of use cases or maybe typical patterns about like what they're doing with their data, what kind of computing they're performing, and based on that, you can essentially infer what kind of environment and deployment architecture that the industry might require for certain very specific use cases. So I think it generally makes sense. Like we have our generic computers, but then there are kind of more specific microcontrollers that would do very specific thing, and they're good at that one. I think we have something similar here. We have generic clouds which are suitable for probably vast of majority of use cases, but for very specific applications that require that have very specific requirements and very strict requirements in terms of SLAs, performance, availability, and whatnot, you might require, you might need that, or at least you might benefit from this kind of specifically designed cloud with specifically provisioned hardware and specific provisioning in terms of like how you actually distribute the data and whatnot. So yeah, I guess it makes sense, but for very kind of specific applications and specific.
So guys, if you have some questions, maybe not related to such bird view in the clouds, please post them to the chat or just go to us and share your camera and microphone and ask our experts. And I'll move to the question about main challenges that we will face in next few years if we consider these trends.
Of view, I can see that there are a lot of developers that tries to write the applications as much using the very high level libraries. And from my point of view, it could be a problem in the future because there can be some latency issues, some throughput issues, and it will be very hard to find the reason for that if a lot of engineers will continue to work the same way. This is my opinion, and I think that every engineer should know about Linux and such system things, but maybe it's like paranoia from my side, but I think so.
Yeah, just to I guess it's more of a generic challenge of having higher level of abstraction, right? Because earlier back in the day, we would deploy everything on directly on the hardware. We will deploy our software directly on the hardware, and we will have like very low level programming languages, and we will have full control on of what is actually going on in the application that we're creating, right? So, and we obviously created a lot of different levels of abstractions on top of that. We have, programming languages that are easier to use, and now we have deployments that are and hardware environments that are basically abstracted from the application development, right? We have serverless development where you essentially deploy your software and you quote unquote don't care about what is going on and where it is being executed. But it also means that you don't really have control around how this software is executed and where it's executed, and you have a lot of those challenges around that. And that's again like I guess a question of finding a right balance between those two things. And in the applications with, again, very strict SLAs, we will have to find solutions for these kind of challenges and for these kind of problems. And I think this is a challenge for the industry in general, and we'll be looking for solutions in the next several years, I would assume.
I want to play devil's advocate a little and take the opposite view to Maxim here, because I think I understand the point that you're making, but also I think that the things that engineers nowadays have to learn to be able to do their job is so much. There's so much that you need to learn. I alluded to this earlier when I mentioned that it's a challenge to find engineering talent that know all of. If you just looking at the big data plane, it's a challenge to find somebody who knows Hadoop, Cassandra, Spark, Ignite, and all these other technologies, right? And how they work underneath, let alone go even lower level down to the kernel level. I think it's getting to the point, or it's probably even gone past the point where it's too much for one person to basically have deep knowledge of the entire stack. I appreciate the point you're making, though, and to some extent I agree. But I think the challenge for us as system designers is to effectively look at how we can make, I suppose, smarter systems that are able to help the developers more. I don't know exactly how the system will do that just yet, right? But I think that's the direction we need to start thinking of looking at. So, from like the Ignite perspective, let's say a node has failed. The user is just using the Ignite client. They have no idea what's going on in the Ignite server side. But if the Ignite client and the server had some mechanism of, effectively doing some debugging amongst themselves and then just reporting that back out to the client for the developer to handle, then that could help. I don't know that that's a good idea. I literally just made that up as I was coming up with that, right? But my point is that I think there is so much for engineers to have to juggle in their head at the moment that knowing the full stack is an impossible task. And it's only going to get worse as these numerous other services and different industries crop up that have different requirements, and you will need to build. So Ignite, Cassandra, all of these databases exist because they were built for specific use cases, specific purposes, right? Having somebody who understands all of those use cases, why they were built a certain way, I think is an impossible ask. So I think we need to look at how we build these abstractions that somehow helps the user more when there are cases where there's some latency or there is some other issue that needs debugging, but the developer using it doesn't actually understand how any of it works underneath. We need to work out how to build smarter systems to help them work that out.
Yeah, in a sense, we've created so many different tools kind of with intention to help developers, but it also makes their lives much harder because now we have to learn all of them. Like, imagine if we could just write everything in assembler. You would only learn how to write an assembler. Very simple life, right?
It's a real catch-22, right?
That's true.
My question to Val, it's speaking about Ignite's next version 3.0. How do you see moving from the second Ignite to the third Ignite?
Yeah, so I mean, it's a hard question to answer right now at the moment.
As a concept, I mean.
Yeah, I understand. Of course, these are just to clarify, right? This is a new major version. These are 2.x and 3.x are going to be incompatible, both on the API level and on the kind of data format level, which means that when you transition from 2.x and 3.x, you need to change the code. And if you have data in your persistent storage that you want to transfer to your new cluster, you will have to transfer the data as well. So there are many things that we're looking at right now. First of all, of course, we'll have some kind of tooling for data migration. So this is something we can automate, and we should automate. So whenever you transition your data, this is something that you should do with a specific tool that Ignite itself provides. So we'll be working on that. And on the API side, so yeah, API is changing, but of course we are kind of the main goal is to prove the usability of the API, but not to kind of introduce something entirely different from what we have in 2.x. So everything that we do in Ignite 3 kind of builds on what we actually have in Ignite 2. And in that sense, we will have similar set of APIs. We will, of course, have the key value API, which will be essentially the same as we have right now, maybe with some minor changes. SQL is still SQL. There is no big challenge there. Compute APIs and service grid APIs will probably remain, if not unchanged, but again, with maybe kind of minor changes that can be easily adopted. So yeah, it will require code change. And of course, it will, require a little bit different approach in terms of how you install the product and deploy the product, because those mechanisms are going to be changed. But the community is putting a lot of effort into simplifying this process of upgrading from Ignite 2 to Ignite 3. And obviously, again, we don't have all those things in place quite yet. So we're going to build, especially in terms of tooling. This is something that we're going to build in the next few months. And but yeah, that's basically like general approach.
Can I ask one question to Valentin about Ignite 3? The short answer to the question is it going to support transactions for SQL?
Yes. The short answer is yes. A little bit longer answer is basically it will just have a single transactional model for all the APIs that you have. So I don't even like to think about this in these kind of terms that we have, like we had in 2.x, where we have transactions for key value APIs and transactions for SQL. I think it's a little bit weird. Ignite just should be a transactional database that supports proper isolation levels regardless of which APIs you use. And that's basically what we're trying to do.
I have a follow-up on that. I think I asked you about this before, but I wanted to double check what the status is. Has the future of the cache store interface been decided yet for Ignite 3? I keep following up on it because we use it.
We discussed that several days ago.
And the second question is about machine learning. Has anything been decided about what's going to happen with that yet?
Yeah, so let me start with the cache store. So there is a question about how the API will look like, and I don't really have an answer right now. Obviously, we do want to keep a certain way of integrating Ignite with external databases. So this is one of the features of Ignite that is being used a lot, and we definitely want to keep it. Whether it will be the same concept of the cache store or not, I'm not necessarily sure. But we definitely want to have a way to integrate with external databases in some way. As for machine learning, I mean, it hasn't really been discussed yet. Obviously, we see it as a useful library, and I see it as a useful library, which definitely can be transitioned into Ignite 3. I don't think it requires any major changes in terms of the API of the actual library. We will have to rework it so that it can work with the new architecture and the new APIs. But generally speaking, yeah, I think this will be machine learning, and there are some other features that, and all the extension features that we have in Ignite, for example, on these kind of things that are essentially built on top of Ignite, will basically come to discussing them after we release 3.0. So that will, I think that will come in one of the future releases. Not in 3.0 for sure. So like the first iteration will not have machine learning or all those extension libraries, but surely there is nothing, no one is against, transitioning them from Ignite 2 to Ignite 3 so that anyone can continue using.
I guess what extensions will be brought to the next Ignite, maybe depending on how many users we have.
it's all about how many people want to do this, want to work on this, and within the community, and also about the prioritization. All those things, again, these are incompatible versions, so we will have to kind of transition. Every single extension or any library that is built on top of Ignite will require some code change in order to adopt it to Ignite 3. Some will require more changes, some will require very little changes, but still there are some. So and for every single feature, for every single library, there is a certain amount of work that needs to be done.
Thank you. So if we do not have any more cloud questions, I can suggest that people will join us on Twitter or on LinkedIn. Will join our virtual meetup to learn more about the next major version of Ignite, of which we discussed recently as we got the third alpha of our third version just a week ago. And I suppose that we will have next alpha like in January or February, maybe, right?
I think January sounds reasonable.
Subscribe to all our lists. I also passed here the link. There you can discuss with our experts and our developers everything that you would like to know about Ignite. Also, Stack Overflow, from time to time, many Ignite developers visit Stack Overflow and answer questions, including some of the people you've seen today during the event. Thank you. That was really interesting to learn what do you think about the cloud trends, because I think I got a little bit confused with them. So thank you for your opinions. Thank you for your help with the event. Thank you for presentations, guys. Thank you for hosting. Val, thank you for joining us. People, thank you for joining us. I hope that soon we will discuss our events for the next year. And so keep watching us. Thank you. And have a good day or evening.
Right.
You are.
All right. Thanks, everybody.
Thank
Thank
you.
you, everyone.
Bye-bye.
Bye-bye.
Bye.